Okay, so in this tutorial, kind of another addition to the grid assignment. I'm going to kind of work maybe a little bit backwards, and in very effective, I think, visual element for the grid assignment is to create a circle of circles. Circle moved out from a center point and rotated around 360 degrees. So I showed a little bit of this in class, but I'm going to demo this. And again, I'm going to work backwards and first talk about how to iterate through to generate an angle. And there are two ways to do this. I'll start with this tutorial to just do it with the push and pop matrix that we've talked a whole bunch about. There's another way to do this using trigonometry, sine and cosine. That's maybe not as intuitive, though it's very effective once you get used to the formula that works for this. In the functions that work with it, it's very easy. But I'm going to try this other way since that's what I've demoed, and I'll work backwards. So I have just a basic sketch. And what I'm going to do is start with just making sure that the thing works the way that I want in one instance, and then I'm going to work towards how do I make it duplicate across a grid. So I'm going to come down and I'm going to draw multiple, and I don't know how many, like 10 circles and 20 circles, I don't know how many, across away from the center, but it's going to be multiple. So we're going to go back to using our for loop that we've talked repeatedly about. So I'm just going to call one, say let r equals 0. So r is just, I'm going to think of this as like the radius, and r is less than 360. And I can do less than here because once it gets back to 360, that would be 0. So I really don't need to draw 0 and 360. I need it to go from 0 to, say, if I was doing every 10 degrees, 350, and then 360 would be 0. So, right, makes a full complete circle. And then I'm going to say r plus equals, and I'll just put a number in here for now. Let's just say 20. So every 20 degrees. And then so this is a for loop, so I have to have a open bracket and a close bracket. And then I'm going to put a circle in here. Right, so the question is, like, where do I put this circle? How is this going to work? So whenever you're trying to figure out transformations and how some of these things work, I always start with just making the object that I'm creating start at 0. And then I'm going to use push and pop matrix to move it around. So I'm not going to drive too much of the position stuff here. But the problem here is if I create a circle that's centered at the center of the world and then I spin it, right, I'm going to rotate it, it's just going to put all those circles right on top of it. So really what I need to do is have the circle a little bit away from the center, and that way it will rotate around. And hopefully you're seeing my little mouse move around. If not, my explanation's not going to work very well. So let's just say 100 is the x position, 0 on the y, and let's just make it, 50. Right? And I'll just go ahead and play. And I have ellipse here. It's making a whole bunch of them. They're right on top of each other, but we're going to fix that here in a second. The other thing, maybe so I can see it easier, I'm going to say no fill. Okay, so boom. Right there, so this ellipse, there's actually a whole bunch of them, but we'll deal with that in a second. The other thing too, I guess I should put cut that. I'm going to put the background, as we've been doing in all the sketches for this assignment, put the background within the draw so it refreshes every single time. Okay, so how do I do the rotate? Well, if I'm going to use rotate, first of all, I want to have rotate here. And how much do I want to rotate it? Well, I want it to be r, because I want it to draw one at 0 and 20 degrees and 40 degrees and 60 degrees and 80 degrees, right, as it goes on. And anytime that I'm going to use push and pop matrix, anytime I'm using rotate or translate, you can get away with not using it, but in this instance, I would just say if you ever use translate or rotate, just use the push and pop functions to reset the transform matrix. I would just say that 90% of the time, this is what you're going to want to do, and it'll save you some grief. So we want it to reset each time. And let's see what we get. Okay, So clearly, in fact, if I do this, let's make it 500. You can see that it's rotating around an origin point. I could even, let's just make this mouse X. Let's make it interactive. Right, so you can see that the arcs, or the circles are arcing around a center point over here. Looks a little weird though, right? Because I have these little groupings of 2 and 2 and 2. Well, I told it to go to 20, 40, 60, 80 degrees. Why is that? And the reason is because the default P5JS uses radians instead of degrees. It's just a different mathematical way of figuring angles, and that can be helpful in a lot of instances. It's not very helpful most of the time, though, in my estimation. So we're just going to tell P5, you know what? I am a human, and I grew up dealing with degrees, not radians, for the angles that I do. So let's see what we have here. Look at that, nice and perfectly evenly spaced. You love it, right? So that's just going through there. Okay, so partial success. The problem here is I want them to spin around the center, and in this case, I want them just to make sure that the whole entire thing is working. I want it to, be here. Now we're going to backtrack here in a second, but I just want you to see that we, before we rotate, we're going to translate, and let's just call it the width divided by height, because I want to put it in the center. And that's a good idea a lot of the times when we're making big designs starting in the center of our composition. And now we've verified that all of those arcs or those circles are emanating from a central point, and they're incrementing in a even distribution, right, across that 360 degrees. Okay, so, well, good job, Dane. You put it here at the center of the screen, but really what I want is for this to be like the grid itself. Okay, so maybe what we'll do, let's comment out. So I just hid that, and I did command / or it's where the question mark is. So let's go back to earlier, and we did for let x equals 0. This is going to be our nested for loop setup, right? So x is less than the width, and x plus equals, I'll just say 100. You could put a variable name. We've done that in class, right? So I'm just going to copy this one, paste that. Of course, this one's not going to be x, it's going to be y. And let's make this the height. My microphone's in the way of me typing, so it's making life difficult. And this one would be the y. And because we have a open in brackets, we have 2 of them here. We need 2 close brackets. If I hit Command B, it formats. So I have let y equal this, y equals height, y equals there. Oh, so not or, 4. There we go. You can see it was giving me a little underline, didn't understand what those variables were. So 4 is what we want. And just to verify that this is working, let's do rectangle. And then this one will say x and y and 100, 100, and we're going to add a little bevel to it. So I'll say 15. So this is going to round off the, and you can see I have my little grid. So that's not bad. Okay, so here we're at a point where we could make some decisions. Let's uncomment this. How do we want this to happen? In fact, instead of that mouse being there, well, maybe I will leave it like that. So I need this to happen at each one of these points. Now, rectangle's doing that. So why don't I just do this with the push and pop matrix? Or how do I glue these 2 things together? I guess is the better way. Sorry, I'm being punchy. How do I glue these 2 things together? I'm going to show you several ways to do this. Important to remember that the for loop, and bear with me, so we start by saying x equals 0. And as long as it's less than the width, 0 is less than the width, then do this bit of code that's inside here and here, right? Within this open and closed bracket. Well, the thing that's inside of that is another loop. And this loop says, well, let's let y equal 0. And as long as it's less than height, it's 0. Then let's go ahead and do this bit of code. Well, this bit of code just says rectangle, and we know that x and y at this point equal 0. But since I'm still in this loop, the loop has to keep looping. So we started off by saying, well, as long as 0 is less than height, do this code. And then once it gets done, it comes back over here and says, you know what? That was successful. Let's add 100 and see if it's still true. Well, y is 100 and it's less than height. So let's do the code that falls in between here and here. And let's do it again. Now, keep in mind, I haven't changed x yet because x said do whatever code is in here. So if there's a loop that goes from 0 to 10, and inside that loop is another loop that says go from 0 to 10, it needs to go 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In fact, maybe this is the better way to explain that. Does this make sense? So both of these loops, in essence, well, the space here, they go to 8, right? So this goes from 1 to 8, this goes from 1 to 8. So that's the way it works. 1, 1, 2, 3, 4, 5, 6, 7, 8. The issue here is we would have, we're going to take this loop and put it within that other loop. So let's just cut that. And I'm just going to hit Command B to format that a little bit. And we do have one problem here, is that we've got push and rotate, that's all working, but I've fixed translate so that it's always going to be at the center. Actually, what we want it to do, we used x and y for the rectangle here. Well, let's just use x and y for the translate. And the translate helps us because we're also going to rotate, so we can put these in combination. And there's we could do this different ways, but this works pretty well, and it's effective to learn how these tools work. So, right, and I've made it interactive, so I can see how they're spiraling out from the center, and maybe get a sense of what the pattern would look like. I do have an issue here in that the pattern ends before it gets to the very edge, and that's because we've said x is less than width. Well, we need it to get to less than or equal to, so that it can draw a set of spirals around these endpoints. So let's just change that. And so I can use my mouse to kind of make my point here. Let's change this from that to 50 maybe. Right? So there's all those spiral patterns happening across, which is exciting, right? Really some interesting stuff going on there. So let's talk about this. So this goes from 0 to 8. This one goes from 0 to 8. Now, I know it doesn't go from 0 to 8. If I figure out this math, it's going to do it 1, 2, 3, 4, 5, 6, 7, 8. It's actually going to go to 9 because it's putting an invisible one here, but that's helping us do this rotate. So if this goes from 0 to 9, this goes to 0 to 9, and let's just pretend that this goes from 0 to 9, even though that's not quite right with the math. And let's pretend that there's an x column and a y column and then a rotate column. So the way that this equation works is x, so this is going to be the first time. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, well, actually 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it just keeps doing that, right? As you can see, x is staying at 1. You can't see, right? I really wish I had a whiteboard. It was set up with my iPad. I'm here in the office. I don't have it with me. So the x just stays at 1 and says, do everything until you're done. Come back to me later. And y says, okay, I'll start doing what I'm supposed to do. And it says, well, I'll start off and do my first loop. And then it says, I'll hang out here until everything gets completed within my loop. So x says, hey, I'm 0. Y says, hey, I'm still 0. And then it gets to this loop, and r says, well, I've got some work to do. 0, 2, 20, 40, 60, 80, blah, blah, blah. And then it goes up and says, hey, y, I'm done getting to 360. And y says, okay, I'll crank 1. X says, again, don't bother me until you get all the way done with your stuff. So it does the loop and works all the way. It's down each one of these, right? Crazy, right? 15 minutes. Just to get to this point, we can create this pattern. But this is pretty good already. It's not bad at all. The last thing I wanted to show here is if you wanted to divide these things up a little bit based on, we talked about functions. In fact, you know what? I'm not going to do that part. I'm going to save that for a different tutorial. I'm going to come back to this and maybe talk about functions as they would relate to dividing these pieces up and putting them into the draw. So I'll save that there. Hopefully it's helpful, my stupid counting. But this is where us being humans, we're not used to how quickly the computer is going through all these loops and doing these things for us. It's almost like a giant spreadsheet working through here. Hopefully this will help. I'll see you in a later tutorial.